All right, ladies and gentlemen, we're getting started on the fun part. So think of this like learning how to simplify fractions. Back in the day, you had to think of different factors that multiplied and did this, did that. To simplify how a fraction looked, to make it easier to understand. So we're trying to get it, and basically we're trying to say what's the simplest version or the smallest numbers that mean the same amount whenever we divided them to get the same decimal or form, so that it meant the same percent, the same decimal, it actually meant the same fraction, all that fun stuff. So we talked about factoring. Well, there's a way to factor in roots as well. So we want to be able to rewrite a root in its simplest form so it's easier to understand and use in our arithmetic and just be able to think about in general. When we have something that's under a square root, we got to remember it's asking anything times itself is going to equal that answer. That radicand. With that in mind, if we factor 108 here, because there's no number that times itself is going to equal 108. You can check your calculator, there's a decimal. It is a number, there's no integer. My brain's just jumping around, I guess. There's no integer. There is a number, but there's no integer that'll give us an answer. So if we check our calculator, which I happen to have one by me, I'm going to do 108, or the square root of 108. Now I'm going to get, it actually gave me an answer in the form we're working on today. So let's get the decimal answer. Square root of 108. 10.39230485, and that's just not a nice number to worry about. So I know the answer with a calculator is 10.39230485. Now, since it didn't end by itself, I'm going to assume that just kept going. I know this is the actual answer, but I don't know that, like, my brain goes, well, it doesn't end, so I don't know exactly what that number is. Now, I've trained my brain a little bit to go that way, but just having a decimal in my answer isn't as nice looking. This isn't even visually good to look at. So what we found was if we go with the same principle as simplifying a fraction, we can do that here. We're going to take the factors, and here I know 2 goes into it because 8's even, and then we get 54. Then we have 2 again because 4 is even, and 27. And here I have 3, because I remember my times tables, 3 and 9. And I have 3 and 3. Okay, so what's happening here is if there isn't a number written in our root, then it's an invisible 2. And that's what square root has always meant, 2. Well, that 2 tells us find pairs. Well, here's a pair, pairs of the same number. Here's a pair of 2's. Here's a pair of 3's. What I'm going to be able to do is this is 2 times 2 times 3 times 3 times 3. That's what all this means. If I multiply all that up, I will get 108. Well, if I take them out in pairs, that means I actually take out the pair of 2 times 2. I take out the 2 because it says take out pairs and just keep that number 2. But I got to keep that same multiplication because I've been multiplying the whole time. I got to take 3. And when I say take out, I mean we take it out from under the radical sign and we put it in front like a coefficient. And whatever is left that I'm not able to pair stays inside of the radical. Now, I can take 2 times 3, and I'm going to get an answer of 6 radical 3, and that means in its simplest form 6 times radical 3 is the square root of 108, or 6 times the square root of 3. Now I can verify that with my calculator. If I take 6 times the square root, I hit the wrong one there, 6 times the square root of 3, and I hit enter, I get the exact same decimal. And I'm going to put it in orange as 10.39230485. And again, I have to assume it keeps going because I hit the end of my screen, which is exactly the same as that number, which is what we had at the very beginning. So we get the same answer even though we've written it a different way. So the idea of simplifying the radical means I look at the factor tree. In this case, I took out pairs because I was finding the square root. And I keep taking out a pair and putting it on the outside, or putting it as a coefficient to the radical. And remembering that I'm multiplying originally, I have to keep that multiplication when I move it out. So here I was able to take out a 2 and a 3, and since I was multiplying already, I just kept multiplying. So 2 times 3 is 6. And then I just kept the radical as radical 3. This right here is a lot nicer to look at and easier to think about than this. This is blah, blah, blah. This is a little bit easier, okay? Now, we can do the same thing even if there's a variable, even if it's not a number. Here, I look at this as factoring 9 and factoring x. Well, 9 is the same as, x cubed. 9 is 3 times 3. There's a pair, and that's what it's telling me to find because of the invisible 2 here. So that's going to go on so this 3 is going to go on the outside of my radical. Now, I have x squared, or x cubed is the same thing as x squared times x. X squared is the same thing as x times x. I have a pair here, so it's going to go on the outside. So this is the same thing as 3 times x times my radical, or my square root of whatever is left. Now, we're going to find out it's not just copy it down. If there's more than one item that's not paired, we're still going to multiply all of our remaining items together. Just like we multiply them on the outside, we have to multiply them on the inside. So here we have 1x left. We took this pair to be 1x, because remember, we take a pair out and keep it because we were square rooting. If we were cube rooting, which I believe we get into next, you're going to have to look for groups of 3 and take just one out to represent the group of 3. So here we have 3 times x, which is just 3x, just better notation there, times x is going to be the same thing as the square root of 9x cubed. So this is our simplified answer.